Okay guys, so to start with, and our main topic today is going to be reviewing of factoring and Pythagorean theorem. So sorry I wasn't able to be there today, so I'm going to start off with these 6 examples. We're going to go through these together. No matter if you had me or Miss Santori or Miss Thomas, factoring you've been seeing since Algebra 1. So we're going to do a review of it today. It's going to be really important by 4th quarter that you still have a good, solid foundation of it, and we're going to keep spiraling it in. Next class is when we're going to be using the Pythagorean theorem a lot, which you can use your calculator for. So, let's take a look at factoring to start, okay? So let's take a look at factoring to start. Remember, this is going to be an example here. The first thing I see is that 5 goes into both of these numbers and that they both have the letter x. So that variable, along with the number, is going to be called your GCF. So I'm going to put the GCF on the outside, meaning I'm going to divide by 5, and you always take out the smallest letter. So that means it's x squared. Remember, your GCF goes on the outside, and then since there were 2 terms in the problem, you will have 2 terms left in your parenthesis. You're reversing the distributive property. So imagine if you took this and divided by 5x squared, you're going to be left with 1x. And then this is subtraction, so the subtraction stays there. 25 divided by 5 is 5. There is not going to be an x here because you already took out the x squared. So this is your final answer. This was just an example of using GCF as a way to factor. Let's take a look at number 2. Since the first number here is 1, there is no GCF. But there's only 2 terms, so you don't do the T-chart that you guys have practiced before if there's 2 terms. Do the difference of squares rule, which means you can jump right away into factored form, which is the form with the 2 parentheses. You do the square root of this, which is x. That goes right here. You do the square root of 16, which is 4. That goes right here. And because the minus is in the middle, and again, this only works with subtraction, you make the first one a minus and the second one a plus. And there's your answer. If you were to go back and multiply these through FOIL or box method, you would get x squared minus 16. Let's take a look at number 3. There are 3 terms here. The first number is a 1, so there's no GCF because they all don't have a variable either. So I'm going to jump to the T-chart. With this, okay, remember on the left column you want numbers that will multiply to 1. So in this case it's 1 and 1. Okay, and we always put our x's here, so let's go ahead and put our x's. Here you want numbers that will multiply to 12. Now at the same time, think you have to add to the middle. So right away the first numbers I think of 12 are 6 and 2. If the first set of numbers doesn't work, try a different set, or sometimes you have to switch these. And remember, how it works is like this. You go diagonally. 1x times 2 is 2x, and 1x times 6 is 6x. Is there any way these 2 will add to make -4? The answer is yes, as long as the 6 is negative and the 2 is positive. So since the 6 had to be negative, you put the negative here, and the 2 has to be positive, you put the plus there. When you write your factors, it goes straight across, top, bottom. And there's your answer. Number 4 is the same process. Okay, just kind of wanted to repeat that, make sure we're on the same page, can remember that. So again, 3 terms, can't divide anything. I'll jump to the T-chart. Only numbers that multiply to 1 are 1, so I'll keep the x's there. Numbers that multiply to 18, now I'm not worried about the negative yet, I will, but right now I'm just thinking numbers that multiply to 18, and the first ones that come to my mind are 9 and 2. Now, I am always have to keep in mind, they have to add to a -7. So if I go like this, 9 times x is 9x. 2 times x is 2x. Is there any way they will add to negative 7? Well, the answer is yes, as long as the 9 is negative and the 2 is positive. So then in this case, I would put the negative here and the plus sign here and then group straight across. And there are your two factors. Okay? Now if you notice with 5 and 6, it's just a little bit different. And it's a little bit different because there's a number in front. See, there's a number in front here and a number in front here. So what you have to do is think, okay, can you divide these all by a value? Is there a GCF? This is no. There's no GCF. So we jump right away to the T-chart. And it's basically the same process. It can get a little trickier because the numbers are bigger, but it's the same process. Numbers that multiply to 2. 1 and 2. And I'll go ahead and put the x's there. Usually this side doesn't change. It's rare if it does. Numbers that multiply to 3, well, that's just 1 and 3. So let's check it. 2x times 1 is 2x. 1x times 3 is 3x. Will they add? Now this one's a little trickier because they will still add. It always adds to the middle. They'll add to negative 5 if they're both negative. But if we were to make both of these negative here, a negative and a negative will not make this negative. Remember, we have to multiply to this. So I'm going to switch the order. Watch what happens. So switch, put the 3 here and the 1 here. Cross those off. Okay, let's see if this works. It should. 2x times 3 is 6x. 1x times 1 is 1x. Now, these will add to negative 5 as long as the 6 is negative and the 1 is positive, which works out because if you notice, to make the 6 negative, the 3 here is negative and the 1 is plus. So these will multiply to a negative 3 and add to that. So you put your parentheses straight across. So your answer is 1x minus 3 and 2x plus 1 when you go straight across. Let's look at number 6 here. Okay. Any number that goes into 3, 11, and 4? Nope. So no GCF. So just jump to the T-chart. Numbers that multiply to 3 are 1 and 3. I'll go ahead and put the x's there. Numbers that multiply to 4. Now you could try 2 and 2. Let's try it. I think they're not going to work, but we'll try it. So 3x times 2 is 6x. 1x times 2 is 2x. They have to add to negative 11. There's no way that 6x and 2x, that's only 8x at the most, or even if they were both negative, it'd be negative 8. So that can't be it. So you cross them off. I'm going to try 4 and 1 now because you couldn't switch 2 and 2. 3x times 4 is 12x. 1x times 1 is 1x. Now this combination will work for them to add to negative 11. The 12 must be negative and the 1 must be positive. So then that means here the 4 is the negative because that's how we would get negative 12. The 1 is the plus, that's how you would get the 1, and you put your parentheses to group them, and you write them, final answer, straight across. So, last thing is reviewing Pythagorean theorem. Now, you may have chosen this for your choice board last class, but even if you did not, now you don't have a choice. You have to practice this because when I see you guys again next class, you must be able to use Pythagorean theorem and apply it to the trigonometry we've been doing. So, just a quick reminder, Pythagorean theorem goes to right triangles. You can see this is the right triangle. So we have A and B are always the legs, and C is always the longest side. It's the hypotenuse, okay? And it's always across from the 90 degrees. So just make sure you remember C has to be the biggest number. So basically for all 4 of these, the last set, is we're going to practice finding the missing number. So in this case, I know I'm finding the C in the theorem, and of course, here's the theorem. Most of you probably remember it, but we'll just write it down. A squared plus B squared equals C squared. So we're going to use this formula, or this theorem, And we're going to use it to find c in this case because that's across from the 90. So 12 squared plus 9 squared equals c squared. So let's see, that's going to be 144 plus 81 equals c squared. 144 plus 81, let's see, 225. And don't forget, your answer is not 225. The last step in Pythagorean theorem is to do the square root. So that means my answer would be 15 for this problem. Let's try this one over here. Again, this one's like the last one because you're solving for c again. It's the hypotenuse, it's the diagonal, it's across from the 90. So 8 squared plus 6 squared, because there's your a and your b, equals c squared. So 64 plus 36, so you get 100. Don't forget, your 100 isn't your final answer though. You have to do the square root of 100, which is 10. So 10 is your final answer. Now, if you haven't already noticed or gone ahead of me here, these two are slightly different because I already give you the C. You're trying to find the A. It really doesn't matter what letter you call it. You're just trying to find the A or the B, I suppose. But notice I give you the C, I give you the diagonal, the side across from the 90 in both senses. So we're going to do it a little bit different, one extra step to the theorem. So here's going to be a squared plus 6 squared equals 11 squared. So you write it like that. A squared plus 36 equals 121. Here's the one extra step. You're not adding 36 with 121. It's on the different sides of the equal sign. So you're actually going to subtract first. So 121 minus 36 makes 85. And then I'm going to do the square root of 85. When I try to do the square root of 85, I got a decimal, so we're not even going to put the decimal number, guys. Just start practicing, leave it as square root 85. So you can leave your answer as that square root of that number, especially if it's going to be a decimal, don't give me the decimal. And that's all there is to it, so let's try one more. So same thing, we're trying to find A here, that's our unknown of the triangle. So we have 4 squared is B, 15 squared is C. So A squared plus 16 equals 225. Again, when you're finding A or B, you have that one extra step where you have to subtract. So 225 minus 16 is 209. The square root of 209, again, that's always your last step. Square root is a decimal, so we're going to leave that as our answer. Square root of 209. So, if you look around the room, okay, to the large dry erase board, there's a yellow station number 1. Then in the back, next to the phone, there's station number 2. In the very back, in between the two curtains, station number 3. Blue paper on the wall side, station number 4, as long as the gold paper, station number 5. So you guys are going to be given a classwork sheet at each station. The first 4 are review of factoring. The 5th is Pythagorean theorem. You choose what problems you want. Each station tells you how many. And each station there's an example, particularly for the factoring problems to help you out. You will turn this paper in when you are finished. Then you will also work on a factoring coloring puzzle today. Finished or not with the coloring puzzle, that will also get turned in. So everything you complete today will be turned in. Okay, and they will be for a classwork grade. There is no homework, but by next class, we're going to get back into the trigonometry and apply this stuff to it. Good luck.